Hey, so on Friday, we focused on that we could count pieces by weighing them again. That we could count by weighing because the numbers that we have to count to are way too big for us to count to. As much as we hate doing math, this is better than actually counting. Can you imagine trying to count to 120 trillion atoms before you weighed them? A couple of problems with that. One, that's too big a number, and two, they're too small to count. Right? So, we've got to worry about three types of pieces. Actually, three types and one more. Okay? Three types of pieces. If it's an element, what type of piece is it? What type of piece makes up elements? Atoms. Usually. Ooh, what do you mean by usually? Well, there's some things that you never find by themselves as atoms, like the air we breathe. The oxygen is always O2. Oxygen makes a diatomic molecule. Okay. Second type of piece is a molecule. That's molecular compounds. And diatomic molecules. And those are the two pieces you had talked about before you got to chemistry class. The third type of piece, well, the other kind of compound is not molecular, it's ionic. And the type of piece that makes up an ionic compound is formula unit. So, when I ask you how many pieces, you have to say what kind of piece it is. Is it an atom, a molecule, or a formula unit? Okay. And those are the pieces we counted on Friday. Today we're going to count the pieces of the pieces. So it's Avogadro's number applied to whatever kind of piece you're talking about. So if I say I have a mole of carbon, it's a mole of carbon atoms. If I say I have a mole of carbon dioxide, it's a mole of carbon dioxide molecules. If I have a mole of sodium oxide, it's a mole of sodium oxide formula units. Okay? All it changes is the type of piece. Okay? So, but molecules have pieces. What pieces make up molecules? Atoms. So I could count the atoms in a molecule. I could count the carbon atoms, and I can count the oxygen atoms in a molecule of carbon dioxide. Okay, everybody okay with that complicated math? Counting. We can make conversion factors out of those. So what do you mean you can make conversion factors? Well, if I had molecules of CO2, however many, I could get rid of molecules of CO2 and change it to atoms of oxygen. What numbers would I put there? Well, one molecule has 2 atoms of oxygen. We just count them. Or I could have done total atoms. One molecule has 3 total atoms. Are we okay with how we can make that conversion factor? We just have to count how many oxygens there are in a carbon. We have to make our own again. Where that came from. It's a new sound. It's desktop. I thought I had this muted. Yeah, I got everything muted. I don't understand where that came from. We okay with that? Formula units have pieces. Just like molecules have pieces. They're made up of atoms too. In sodium chloride, there's a sodium atom and a chlorine atom. And I can do the same thing with formula units that I did with molecules just a second ago. Make conversion factors to go to atoms. Okay? But formula units have a second piece as well. They're also made of ions. For example, calcium sulfate, CaSO4. There's one formula unit of calcium sulfate, has one calcium atom, one sulfur atom, and 4 oxygen atoms. So I go from formula units of calcium sulfate to atoms of oxygen, or formula units of calcium sulfate to atoms of sulfur. Okay? Or I could say from formula units of calcium sulfate to total atoms. In one formula unit of calcium sulfate, there are 6 atoms. 2 calciums, calcium, and sulfur, and 4 oxygens. Okay, that? But that's not the only kind of piece. This is just like carbon dioxide a second ago, but calcium sulfate has a different way you could break it up. Calcium sulfate is made up of ions. It's made up of calcium ions and sulfate ions. So there's a total of 2 ions. So I can go from formula units of calcium sulfate to calcium ions, calcium formula unit to sodium sulfate ions, or calcium sulfate to formula units of calcium sulfate to total ions, 2 total ions. We get that? Okay. And guess what? So we can make conversion factors out of those too. Okay, so let's try a few of these. So if you're going to make a conversion factor, how many oxygen atoms in CaCO3? Let's go with the obvious answer. How many oxygen atoms are in CaCO3? That would be 3. Are we okay with that? So you got to be silly asking that question, Mr. Green. That one's obvious. Okay, let me make it harder. How many oxygen atoms in Al2SO43? 3 SO4s would be 12 O's. How many ions in CaCl2? And remember, the name of the ionic compound is the name of the ions. Okay? So CaCl2 is calcium chloride. How many calciums? 1. How many chlorides? 2. So how many ions? 3. How many ions in NaOH? Well, the name is sodium hydroxide, so there's 1 sodium, 1 hydroxide, 2 ions. How many ions are there in aluminum sulfate? Okay. Well, one formula unit has aluminum and sulfate, 2 aluminum, 3 sulfates, 5 ions. How many atoms? Ah, 17. 17. You got to include the 3 S's too. And include the 3 S's too. Everybody see 17? So it's 17 atoms, but only 5 ions. Okay? Do I count the polyatomic ions as a group, or do I count them separately? Pretty doable? Okay, so let's take those and make some conversion factors. So in AlCl3, if I want to make a conversion factor that gave me Cl atoms, I'd get rid of formula units of AlCl3 and change that to atoms of Cl. And I could say, in one formula unit, how many atoms of Cl? 3. That's my conversion factor, to go from formula units to atoms of Cl. Okay? To go to total ions, I'd start off with formula units on the bottom again, AlCl3, and change that to ions. And I can't say ions of anything because there's different kinds of ions. I can't say there's not ions of AlCl3. There's ions of Al and there's ions of Cl. And in one formula unit there would be 1 Al, 3 Cls, 4 ions. Doable? Yeah. So, how many atoms are there in 4.9 grams of sodium nitrate? There's 5 in NaNO3, but that's not in 4.9 grams of it. That's in one formula unit. So I have to start off with the 4.9 grams of NaNO3. I need to get rid of grams of NaNO3 and get moles NaNO3. And 1 mole is 22, give me a place I can write, 22.99 grams of Na. 14.01 grams of N. So that's 26, 27. And then 3 times 16.00 grams for oxygen. That's 48.00 grams of oxygen. So 48 and 37 is 85. It's 85.00 grams of NaNO3. Then get rid of moles of NaNO3 and turn into pieces. What kind of piece is NaNO3? Is NaNO3 an atom? NaNO3 an atom? No, it's not on the periodic table. So isn't it ionic? Don't you think? And if it's ionic, the piece is formula unit. And 1 mole is a really big number of formula units. So I got rid of grams, change it to moles, take the moles and change them to formula units, and then I'll get rid of formula units and change it to atoms. And how many atoms? Well, now's the time to use the 1 Na, 1 N, 3 O's is 5 atoms in a formula unit. So on my calculator, that's 4.9 divided by 85 times Avogadro's number times 5. I get, with 2 sig figs because of the 4.9, 1.7 times 10 to the 23rd atoms. I can't say atoms of anything because some of the atoms are Na, some are N, some are O. This is just one more step than what you did for homework over the weekend. Now, what if I'd asked you ions instead of atoms? Well, you would have started in the same place and done almost everything the same. Change it to moles of NaNO3, just like we did on the other side. Oh, I forgot the Na part of it. Erase. I pushed the button. Erase. 1 mole is 85.00 grams. And then we did 6.022 times 10 to the 23rd formula units. NaNO3. And that was 1 mole NaNO3. And then we had the third conversion factor. You want to go from formula units to ions. In one formula unit there are, well, how many ions in NaNO3? It's Na and NO3, so that's a 2. Okay. So that's what we're doing different today. Way too many.